All right, so let's say that we have these two equations here. So we have y equals 5x plus 1, and we also have that y is equal to x minus 3. X minus 3 is down here in green. It's this bottom line. And we want to find the intersection of these two lines. Well, if we graph this, we can see that the intersection is right here. These two lines cross at the point -1, comma 4. However, if you think about what this point is, this is an x and a y. So this is where each line has the same x and y value. So when you find intersection points algebraically, really this is what you're looking for. And so here, notice that these lines are both set equal to y. So if y for the first equation equals 5x plus 1, and y for the second equation equals x minus 3, then I can set these two, 5x plus 1 and x minus 3 binomials, equal to each other. So now if I want to solve for x, I can just do a little bit of algebra, combine my like terms. So I subtract x from both sides and subtract 1 from both sides. So now I get that 4x is equal to -4. If I divide both sides by 4, I get x is equal to -1. And that's what I found graphically. To find the y coordinate, I would take this and plug it back into the original equation. This seems like a good method, but not always do we have the variable isolated. This is called a system of linear equations because there are more than one equation. And these are linear equations, meaning they give us lines. There are two fundamental methods that we can use. The first is solving by substitution, which is what we pretty much just did. So what we can do is we can solve either of these equations for one variable. So for example, I can solve this first equation for x, and then substitute that back into the second equation. Now you can do whatever you want. I can solve, there are technically four of these here. I can solve for any one of them. Now, I wouldn't want to solve for anything in the first equation personally, because I see I have a 2, a 5, and an 18. So no matter what I solve for, I'm going to have fractions. However, if I look at this second equation, if I add x to both sides, then I get y is equal to x minus 12. Now I have this y isolated, and that's perfect. So if y is equal to x minus 12, I can take this first equation, which is 2x plus 5y equals -18, and notice that where I originally had a y, I left it blank because if y equals x minus 12, I'm going to put that x minus 12 and substitute it in for y. Now I distribute this 5 in, so I get 5 times x, which is 5x, times 5 minus 12, which is 60, is equal to -18. 5x plus 2x is 7x. I can add the 60 to both sides. So if I add 60 and add 60, this is really the same as 60 minus 18. So that's going to be 42. If I divide 7 on both sides, I get that x is equal to 6. I can take this x and I can plug it back into anything. Since I already have y solved for, I know that y is equal to x minus 12. So if I substitute again the 6 in for x, I get that y is equal to 6 minus 12, which is -6. So my solution is 6, comma, -6. Notice I write this as a point because this is a point. These are two lines, even though they're not written in slope-intercept form, and this point represents the intersection of those two lines. Now another way is elimination, where I could get rid of one of these variables. So notice with this system of equations here, I have two variables in two equations. If I multiply, I can get rid of one. So if I look at this bottom equation, I have an x and an x. If I notice, this negative 2x is half of this 4x. So what if I take this entire equation and I multiply it by 2? The top equation is still 4x minus 5y is equal to 2. And the bottom equation is now negative 4x minus 20y. And I multiply this negative 26 by 2 to get negative 52. If I add these together, I get 4x minus 4x, which cancels out to 0. Negative 5y plus negative 20y is negative 25y. And then a positive 2 plus a negative 52 is negative 50. If I divide both sides by negative 25, I get that y is equal to 2. Now, from here, I can substitute this back into either one of the equations. It doesn't matter which one, but I can go back to the first one, and I could say 4x minus 5y. But again, y here is 2. So I substitute in 2 for y. So I get 4x minus 10 is equal to 2. So 4x is equal to 12, or x is equal to 3. So my final point of intersection is 3, 2. And again, this represents an intersection point of these two lines. Now again, you could use substitution for this problem, and you could use elimination for this problem. However, sometimes they don't always work nicely. For example, maybe you could use elimination, but you have to do a lot of multiplication. Maybe you can use substitution, but you're going to have fractions no matter which variable you solve for. So just remember which method, or remember both methods, so that you can choose which one would be more appropriate for the problem you are solving.